The word understand is used frequently among English speakers, and looking at the Google Books Ngram viewer, this frequency only seems to be on an upward trend. Because it is such a ubiquitous term, it is natural to assume that the individuals who use it, if asked to define the word, would provide relatively equivalent responses. However, this is not the case. When asked questions regarding the definition of understanding, users on Quora, a question and answer website, responded with a wide range of answers. Understanding was defined as being present to some information, experience plus knowledge, making correct predictions, reasoning and the absence of reasoning, the ability to shed premature conclusions, creating an internal model of the real world, and whatever one wishes it to mean. This lack of agreement suggests that those who understand do not understand understanding. Myself once included, I would like to share the recent conclusions I have made about understanding, as they may have important ramifications for education and artificial intelligence. Firstly, I would like to discuss what most individuals agree is not understanding. John Searle, a well-known American philosopher, proposed the following thought experiment to challenge the notion that computers could one day genuinely understand material. A man who could not speak Chinese stood within a closed room with two slots. A Chinese speaker outside the room inserted Chinese messages into one slot and awaited a response from the other. The man inside used an instruction manual to create a plausible response, and after outputting the result, the Chinese speaker was convinced that another stood within. John Searle argues that there is little difference between his thought experiment and any Chinese-speaking computer. As the man inside could not understand Chinese, any Chinese-speaking computer one could create cannot either. Searle states that his Chinese room argument is evidence that machines are syntactic, not semantic. What allows humans to understand, according to Searle, is semantics. While Searle's Chinese room is a wonderful argument and has been the starting point for many discussions about the mind, many individuals, including myself, disagree with Searle's conclusions about understanding. To illustrate my position, I need to firstly describe my specialized view of the word data. Many great philosophers and scientists agree that color is a product of the mind, not the real world. In other words, two different individuals may observe the same strawberry and have two different experiences. One common argument against this position is that, if it were true, no agreements about color of an object could be made. However, this view neglects the possibility that two different individuals may have denoted two different experiences by the same name. Agreement only occurs because of our commonality in labeling, not because of an equivalence in experience. But if colors can be unique to everyone, what are colorblind tests actually testing? Let me give a hypothetical scenario. When a doctor showed this image to two patients, one saw image 1, while the other image 2. Both patients perceived the number 12, even though their color experiences were not entirely equivalent. Because the doctor consequently diagnosed both patients as non-colorblind, this demonstrates doctors are not interested in what the patients experienced, but instead whether their experience allowed them to categorize the inner circles. In other words, when the non-colorblind individuals inform the doctor that they perceived the number 12, they are stating that they perceived certain circles as similar in color, while others as different. Any individual who can do this is considered to have full color vision. But suppose a blind individual with technology that transmutes images into sounds also perceived the number 12. And when the doctor pointed to a pair of inner circles, they accurately determined if the circles were similar or different in color. Could they then be classified as having full color vision? I would argue yes. For ease, I have labeled the blind individual as person C and the two non-colorblind individuals as person A and B. The only difference between person C and person A or B is the same difference between person A and person B. Having a different experience shouldn't disqualify person C from being labeled as having full color vision. With these ideas, I can now explain my definition for data. While person A, B, and C did not share the same experiences, they shared the same data. Data is anything which reveals the relationships between objects, which in this case were the inner circles. Notice how without the 4 pieces of data, the 4 objects are completely indistinguishable from one another. And while the example I just gave is that of continuous data, discrete data also exists. For example, these objects, or animals, can be assigned to 3 types of data: birds, fishes, and mammals. The reason this is discrete data is because if I were to pick a pair of objects, rather than know the level of similarity, I would only know if the 2 were equivalent or not. Now, although continuous data and discrete data are different, both types of data can be assigned to the same set of objects, as demonstrated here. Continuous data is superior to discrete data in terms of revealing the relationships between objects, but there's never a case where data reveals 0 relationships about some objects. In other words, a colorblind individual who experiences some color data is not necessarily a blind individual who experiences no color data. Data can also be both continuous and discrete. One example is dividing the continuous color spectrum into 7 discrete colors, so both a scale and specific categories exist. I could give over 100 examples of different data types, such as color, weight, distance, speed, and etc., but there are 2 types I want to focus on: syntactic data and semantic data. Using the word syntax and semantics, Searle was referring to the appearance and meaning of a sentence. So I will use these definitions. Given 4 objects or sentences, individual A assigned discrete syntactic and semantic data to each. She recognized none of the objects to be equivalent in appearance or syntax. However, she found 2 sentences to be equivalent in meaning or semantics. Why did individual A use discrete rather than continuous data? Before answering this question, it should be recognized that an individual who assigned either type correctly to the 4 sentences demonstrates that they have experienced some semantic and syntactic relationships. Returning to the question, it is because I made the example to model Searle's version of a computer, which, as I will now demonstrate, can experience discrete data. In order for the non-Chinese speaking man to compare the inputted symbols with the instruction manual symbols, he must be able to experience discrete data. It is because of this ability that Searle's argument breaks down. When I say that Searle's argument breaks down, I do not mean that the man in the specific situation Searle describes can experience semantics. It breaks down because I can provide an example where this man would experience semantics. Rather than place the man in a room where syntactical data is both the input and output, I placed him in a new room where he continued receiving syntactical data, but he instead outputted semantic data. His instruction manual, illustrated here, guides him to output a certain number for every sentence inputted. These outputted numbers are discrete data. Notice how for sentence A and C, the assigned semantic data is equivalent, but for sentence A and E, it is not. Because the man can experience discrete data, as demonstrated earlier, he quickly began experiencing the instruction manual in this connected way. Sentence A, "What is your age?" and sentence C, "How old are you?" were experienced as syntactically unequivalent, but semantically equivalent. If a real individual was asked to read some sentences and discretely classify them according to meaning, they would experience the same data as the man in the room. This is analogous to how the blind person C and the non-colorblind persons A and B all demonstrated full color vision although using different methods. It should be noted that although Searle's man may not be capable of experiencing continuous semantic data, he definitely cannot be classified as incapable of experiencing any semantic data, a state which Searle emphasized as the absence of understanding. My modified version of Searle's Chinese room demonstrates that it is not semantics, a type of data, but more generally the concept of data which is bound to understanding. One individual who studied the techniques by which data is manipulated is Charles Sanders Peirce, an American philosopher, logician, mathematician, and scientist. He described 3 techniques, deduction, induction, and abduction, which today are widely accepted as the 3 ways of reasoning. A represents an object, B and C represent different types of discrete or continuous data, and the word is represents assignment. The technique the man in the modified Chinese room used was deduction. If the sentence, "What is your age?" is syntactic data 1, and all syntactic data 1 are semantic data 1, then the sentence, "What is your age?" is semantic data 1. These 3 forms of reasoning are the 3 techniques humans and possibly machines use to understand stuff, and this shouldn't be surprising. A situation where understanding is experienced and reasoning, as defined by Peirce, is not used, does not exist. Just like how the label of a C chord really encapsulates 3 inversions of the same keys, what we have labeled as understanding really includes 3 inversions of the same concepts. Thank you for watching.